Hey everyone, today we're going to practice the exponent rules which we learned last video. Um, yes, last video we learned the exponent rules and we used some more simple questions to solve regarding those rules. But now I want to practice a bit more advanced ones just so you guys are ready for the assessments or tests that you have coming up, or just if you're interested in knowing them. Okay. If you have not seen the video named Exponent Rules, definitely check it out because this might not make as much sense. So we're going to start off. I'll write a few questions and you could please feel free to pause it and try to solve them. So we got y to the power 7 squared, be number 1. Number 2 is going to be mn to the power 5. And 3 will be 5m to the power 3, n to the power 0. Okay, so using exponent rules that we learned last lesson, when you take an exponent of an exponent, all we do is we multiply it, I forgot the equal sign, by the exponent, right? So this is going to equal y7 times 2. We multiply the exponents together. This is going to equal simply y to the power 14. Okay, fairly straightforward. Now this one is saying that we have mn and we're multiplying it by itself 5 times. So this is just going to be equal mn times mn times mn times mn times mn, and we use the product rule. So each of these m's and n's has no exponent, which means technically it has an exponent 1. So all of them have exponents 1. And we're just going to add them all together. And since there's 5 of each, it's just going to be m to the power 5, n to the power 5. Awesome. Okay, now this one is just a kind of, not a trick question, but you have to understand the exponent rules, right? So we have 5m to the power 3. And when we have any variable that's not 0, so we're assuming that this n is not 0, and we raise it to the power 0, it's just going to equal 1, which just equals 5m to the power 3. Awesome. Let's do some more examples. Let's try h to the power negative 3 times negative, or to the power negative 6, and here we will try well, that's good. 5 times m multiplied by n to the power 3 to the power 0. So let's start. Now, when you take an exponent of an exponent, we just multiply them together. So it's going to be h to the power negative 3 times negative 6. That's just going to be equal to h to the power 18. Now this one, according to BEDMAS, we do brackets, but there's nothing to do in the brackets, so the next comes exponents. So we're going to raise these variables to the power 0, right? And technically, the m has the exponent to the power 1, so we'll do 1 times 0 multiplied by n as the power 3 times 0. This is going to equal 5m to the power 0, n to the power 0, which equals 5 to the power, just 5 times 1 times 1, which equals simply 5. Okay, now we're going to get a little more advanced. Okay, let's try 1 over 4 to the power negative 2. Second question will be 1 over 3 to the power 4. The third question will be let's make it 5 d to the power negative 1 e to the power negative 2 and f to the power 0. Well, when we have a negative exponent, we simply flip this upside down, right? We flip whatever variable or number over to the numerator, and if it's on top and is a negative exponent, we put it to the denominator. So this is going to equal 4 to the power 2. And technically it's over 1, but we're not going to show that. And 4 to the power 2 is 16. So this just means 16. Now, notice how there's no negative symbol, so we don't have to flip it on the exponent. So this is just going to be 1 to the power 1 over 3 to the power 4, which is let me just check that to be sure. Oh, it's 81. 1 over 81. Okay. Now, notice how there's no technically there's no operation going on here, but we don't like answers in math. We don't like answers in negative exponents, right? So what we're going to do is we're going to make this so there's no negative exponents. So let's solve. When we have 5 and when we have a negative exponent, we're just gonna flip it and put it in the denominator. So this is going to be d to the power 1, or we don't have to write the 1, and then e squared because we flipped it. And f to the power 0 just means it turns to 1. So this is just simply going to equal 5 over d times e squared. Awesome. Okay. Now we'll get into ones that are a little bit longer. So let's try number 1. So we're going to simplify here. We're going to do 4m to the power 3 multiplied by n. We're going to multiply this by the power of negative 2. Well, let's do it. So we're going to take the negative exponent of all the numbers inside, right? So this is going to equal 4 to the power negative 2, m to the power 3 times negative 2, because an exponent of an exponent means we multiply it together. And then n, 1 times negative 2. This is going to equal 4 to the power negative 2. We'll just simplify this a little bit. So m to the power negative 6 and n to the power negative 2. And they're all negative, so what we can do is we can flip it over and write them as positive fractions. 4 squared, m to the power 6, and n to the power 2. And then what we can do, we can actually simplify this further because we have a number to the exponent, so we can just write that as a number, because 4 squared is 16, and then we have m to the power 6 and n squared. Okay, do 1 or 2 more. I'll write down 2 this time. So let's do 10 times p to the power negative 3 times y to the power 7 for the exponent negative 5. And we'll do 2. So we'll do square bracket, another bracket, and this is going to be a to the power 3 times b multiplied by a squared times b squared power negative to the power 3. Okay, so let's solve this. So we'll do it one step at a time. We'll take the negative exponent of all of these numbers. So 10 to the negative 5 times p, it's going to be negative 3 times negative 5, so it's going to be p to the 15. And y, 7 times negative 5, that's negative 35. Now let's rearrange this because we do not want negative exponents in the answer. So we're going to leave the p on top because it's a positive exponent, and we'll rewrite the bottom as 10 to the power 5 and y to the power 35, as they've been flipped, so they no longer need negative exponents. And then we could actually further simplify this by expanding the 10 to the power 5, which is 100,000, 5 zeros, and then y to the power 35. Kind of looks a bit messy, so I'll just cut that off here. That is the final answer. Okay, now for the last one, you'll notice there's two sets of brackets. So we always have to follow BEDMAS. So brackets come first. In the innermost brackets, there's no operation that can be done, but then we go to the next brackets out, the square ones, and we realize there's a multiplication operation going on here. So we're going to start with that. Leave the square brackets because we still have an exponent attached to them, which is another operation, and we'll multiply these together, which is the product rule, which means we just add the exponents for each of the same variables. So a to the power 3 plus 2, and then b to the power, technically is a 1, so it's going to be 1 plus 2 to the power 3. Simplify that as a to the power 5, b to the power 3 to the exponent 3. And now we're just going to multiply these out, the exponents, so this is going to equal to a to the power 15 multiplied by b to the power 9. Okay, well, I hope you guys understand this, and just definitely keep on practicing. Rewatch the video if you need help, and the past video if you want to learn the rules. And good luck on whatever math quest you have going on. And good luck, and please leave comments or concerns if you have any, and I'd be happy to help. Thanks.